out of it to get to you.
Now you are.
Okay. Now, how's that? Can we see that?
Good.
Okay. Uh, can you see my cursor now?
Yes.
Okay, we've got a firebox here that creates heat from the combustion of the coal. The heat goes through tubes in the boiler, transfers the heat to water. The water boils, creates steam, goes up here to the steam dome. The excess goes out the stack and is assisted by some help with the flues. And the idea is the creation of the steam can be used for locomotion. This this is out at Ravenna. This is a boiler in its basic form. What you have here is the firebox at the back. Then you have the boiler itself, these three courses, and then up front is the smoke box. These three courses are where the heating flues are. This is the firebox, and all these nubs are called stay bolts. And what they do is they hold an inner and outer sheets around the firebox, and there's water between those sheets. Here's in the process of working on, I think it's a C&O engine in the shops. We have the advantage of being able to look inside the firebox and see the beginning of the boiler itself here with all the flues. And the two side panels have been cut away to be replaced so that you can see into the firebox. And the interior here was whitewashed to help see what's going on in there. And a good thing for that, because if you looked in here normally, you'd see nothing but black. These are something particular to this design of locomotive. These are tubes and a double wall plate in the firebox itself for help collecting the heat and transfer it to the water. The water from the boiler can come up this tube, get heated, and go up into the top of the boiler. And here's the stay bolts, and you can see right up here at the top, the stay bolts are linking the inside and outside sheet. Here's the precision drilled replacement sheet on the other side of the locomotive. This is the outer sheet. I assume the inner sheet is already in there. Here's another example of a cutaway of a locomotive showing the boiler tubes, which are the small tubes. The superheater tubes are the larger tubes. This big tube up here at the top comes from the steam valve and is controlled by this rod, which is controlled by the cab and the throttle, which is off to the left. And this opens the valve for the steam at the top of the boiler to come down through the valve and go forward to the pistons or the valves and then the cylinders. The superheater tubes, there's one of them shown here. The difference between saturated steam is steam that is just basically just above 212 degrees, and it has only attained enough energy to keep it in a vapor state. But extra tubes here take the saturated steam, which is up here in the top of the boiler, and it takes it and it sends it through these tubes out and back again. And the larger diameter of the superheater tubes puts extra energy into the steam that's in these superheater flues, and superheater tubes and creates high pressure high pressure steam. Here's another look at what's going on there. These are the superheater flue. This is a superheater tube. The tubes come out into the smoke box, go up into the superheater box here, and basically one side of the box takes saturated steam, sends it through the superheater tubes, comes back as high pressure steam, and I forget the proper word for that. Superheated steam, I guess. And then these pipes take the high pressure superheated steam down to the valves for delivery to the cylinders, the piston cylinders. Any questions so far? I didn't lose anybody. Here's another diagram showing where you have the products of combustion here, the heat going through the flues and out, and then the saturated wet steam goes up in here to the steam dome, and then the saturated steam comes down, goes through the superheated tubes, and by the time they come back, they are into as superheated steam and high pressure steam. And then this is a throttle body. So in the case of this engine, the throttle is controlling the valve here and not in the steam dome. And the superheated steam goes under high pressure to the to what's called the steam chest and the valves and then the cylinders. This is actually a diagram of a model locomotive, but it shows a lot of the parts of a steam locomotive. And I don't know about you guys. I'll have to minimize this. Okay, you got start up here. This is a sand dome. This is where sand goes down and gets injected in front of the wheels for traction. Got a handrail. The dynamo is a steam operated turbine that runs a generator for electricity for the engine. The deck plate here is the plate that the crew stands on between the tender and the cab of the locomotive. Coal bunker. This is a brake cylinder under the tender. This is the water hatch where the water goes in. Backup light. Coupler. This is a crank pin. This is the pin on the side of the driver. The rods going back and forth are the connecting rods. The main rod is the rod that comes down from the cylinder to actually push the drivers. You've got the cylinder, and above it is the valve, and the piston rod comes out of the back of the cylinder here, and this is the crosshead link. This is the link that keeps the piston shaft straight. Otherwise, it would bend due to the forces on the main rod. Okay, what's going on here? All right. This is a Mikado on the Durango and Silverton, and this just shows some of the other things on the locomotive. You got your stack, you got your number board and headlight. This is this sand dome, and you got your bell here, and then this is the steam dome. This is air reservoir tank, and these are cooling coils for when the air goes through a compressor, it gets real hot, and then these coils cool down the air before they go into the tank. This locomotive has its counterweights on the wheels separate on the outside of on the end of the axles for the locomotive wheels. The wheels are actually inboard on the frame. This little valve right here, it's part of the mud valve system. It comes down from the lower corner of the boiler where crap gets collected, and a valve opens and allows this to blow all that stuff out of the bottom of the boiler on either side of the firebox to help clear it out. They do this a lot on bridges or in open areas. You see this big plume of steam shooting out the side of the engine. That's what they're doing, is they're doing what they call blowing out the mud ring. Here's the other side of a Mikado locomotive on the Cumbries and Toltec, showing much all the same things, except this side is where the piston is, air compressor. And I've learned just recently that this is a two-stage compressor. It takes steam to run a piston up and down, to run a piston that compresses the air. And then it goes to the next stage, and another steam piston compresses the air even more. And that's what goes into these tanks, and the tanks provide air for the train line. This is a detailed shot of the side of what goes on with the valve gear, starting with the piston rod that comes out, and this is the guide that keeps the piston shaft straight. Here's the main rod that pushes on the pin for driving the wheels, and this curved bar here is the reverser. And right now the engine is in neutral, but this part of it is either raised or lowered to go from forward to reverse. And this rod going up here to this crank, that's a lubricator. As this goes back and forth, this lubricator pumps lubricants to the important places on the bearing surfaces. This upright here is the end of the valve cylinder, and this is operated essentially, if you're going whatever direction you're going, this is arranged so that this piston, as the cylinder goes all the way, the piston in the cylinder goes all the way toward the front, this then the valve then goes toward the front and allows steam to come in at the front end of the piston and push it back. And likewise, when it gets all the way back, then the valve changes position and puts steam in to push the piston forward. It's all called monkey motion. This is back at Ravenna again. This is the C&O, and this is the sand dome with all the valves and everything controlling sand for traction on the tires, on the wheels. And this is when you take that 1 pound of water and you make it steam and expand it to 1,600 times its volume, that creates pressure. But having the boiler under pressure up to 350 psi keeps water in a liquid state, even though the temperature would dictate that it's that it wants to be steam. One of the most important things about operating a steam locomotive is that the water level in the boiler must stay high enough to stay above the crown sheet. And if we go back far enough, the crown sheet is this area right up here. If the water level ever gets too low, there's nothing to keep this metal from melting and getting weak. And all this 350-pound pressure pushing down on this, if all of a sudden this plate ruptures, all of this liquid water that is at a very high temperature and wants to be steam, all of a sudden it wants to go to 1600 times its volume. And if this sheet metal breaks here, all of that water instantly turns into steam and you have an explosion. And this is the frame of the locomotive. And what you're seeing here is all the superheater tubes and the front of the locomotive, the cab and the boiler and every other part of the locomotive is probably a block or block and a half away behind you. There was a series in the Chicago Northwestern Historical Society magazine about the rebuilding of Chicago Northwestern's 1385. And there's some things that are kind of interesting here. And I wish I can't make these larger, unfortunately. But what you're looking at is down here on the lower left is the valve mechanism that's up in the steam dome up here. This is the mechanism that takes the throttle rod right here, goes in here, and it opens a valve to allow steam in the steam dome to leave and come back down into this tube here and go through this pipe to the which is going forward up here in the top of the boiler down to the pistons, the valves in the piston. And this is just some details showing how it works. Here's the front smoke box part of the boiler with these two big pipes up here will be the pipes going down to the valves in the cylinder. The bigger tubes here are the superheater flues, and the smaller pipes are the normal flues. Same thing down here. This shows the superheater tubes being installed. Here are the pipes going out and down to the cylinders. And what they're doing here is this attaching that pipe and the mechanism at the back head of the boiler where the basically where the throttle rod comes out that goes to the goes to that valve. These are the valve inserts that go inside the valve to control the steam going to the pistons. This is the piston that's in the cylinder with grooves for the sealing rings that seal the steam from leaking around the piston. Here's the piston shaft right here. And this other issue here talks about the fire grates. The fire grates are right down here in the bottom under the fire, and what they are adjustable to allow air to come up through the fire to help combustion. But then the fire grates can be controlled from the cab, and they rock to drop the fire. Here's the Here's the fire grates up here in the upper left-hand corner. All new connections and to the grates and the mechanism for tipping them. And then back here, this again is in the steam dome on top of the engine. This is the mechanism for lifting the valve opening, which goes up right here to allow steam from the dome to go down and go down. Oops. To go down through this pipe and up toward the front to the cylinders and the to operate the piston. Right here, after it's all assembled, you can see down here the throttle arm that the engineer works for pulling out and pushing in on this rod that goes down through and operates this valve here. And this is the shaft seal that goes through the top of the boiler to seal that shaft where the throttle rod goes through. And this has more to do with attachments of the things on the back head, and they're assembling the things on the back head here for in the cab. Okay, that's part one.